So here's the last piece of number 6 from the 2013 AB exam, and in this they want us to find a particular solution to the differential equation that's given that passes through the point 1 comma 0. So this differential equation, if we're going to try to solve it, we're going to have to try to use the method of separation of variables. So if we're going to separate our variables, what we're going to need to do is we're going to need to make sure that we get the x's and the dx on one side of the equation and the y's and any dy on the other. So I think we can do this in really 2 steps, and I'm only going to take one line to do these 2 steps. I need to move this e to the y over to the left side of the equation with the dy. So I'm basically going to divide both sides by e to the y, and then I'm going to multiply both sides by dx. So I'm going to have this 3x squared minus 6x being multiplied by dx. So the variables have now been separated, and if we're looking to solve this differential equation, what we're going to have to do is we're going to have to get rid of the differentials by finding an antiderivative on each side of the equation. So the antiderivative on the right should be pretty simple. The antiderivative on the left is going to be a little tricky because we have this fraction right now. What I'm going to do is I'm going to move the y across the fraction bar and into the numerator. I'm just going to change the sign on its exponent in order to make that happen. And there is an integral formula that most textbooks will have for the antiderivative of e to the negative y. It's actually negative e to the negative y. You can also get that same result by letting u equal that exponent and going from there. I'm just going to apply the integral formula though. So the antiderivative of e to the negative y is going to be negative e to the negative y. I'm not going to add a constant of integration on this side of the equation. I'm just going to add it on the right side, because what we want to do is we want to solve for y. We want to find what this function y equals f of x is. So when I move the constant from this side over to this side, I'm going to be combining 2 constants, and I'm still not going to know the value of that, so I'm just going to leave a single constant on the right side of the equation. And then the antiderivative on this side should be pretty easy. We're going to copy the 3 since it's a constant, add 1 to the exponent, divide by the new one. Copy the constant, add 1 to the exponent, divide by the new one. And then since that's an antiderivative too, we'll tack on our plus c there. And if you clean this up a little bit, these 3's cancel, so we'd be looking at x cubed. And then minus, well, 6 divided by 2 is 3, x squared, and then plus c. Now, at this point, you have one of 2 options. What usually is easier to do right now is to plug this ordered pair in for x and y and solve for your constant c. If you do some work to solve this for y, and you write out a general solution that solves for y, although that's not necessarily going to be wrong to do, you're going to create more work for yourself in trying to plug these values in for x and y and then resolve for c. So I'm going to solve for c at this point. So I'm just going to kind of bring myself up here, and I'm going to apply the initial condition. I'm going to apply the point 1 comma 0. So I'm putting 0 in for y, and I'm putting 1 in for x. And if you're trying to solve this for c, well, e to the 0 is 1. So over here we have negative 1. And then right here that's going to be a negative 2. And then to solve for c, it looks like we're just going to add 2 to the negative 1. And we're going to get our value of c. So c is equal to 1. So now what we need to do is we need to take this equation, negative e to the negative y, equals x cubed minus 3x squared. So I'm just copying the general solution that's written down here, and I'm going to put the value that we just found for c in place of c. And then to figure out what y is, I'm just going to have to do a little bit more algebra and solve this for y. So I'm going to divide both sides by negative 1, basically, to get rid of this negative in front of the e. So when I divide both sides by negative 1, I'm looking at negative x cubed plus 3x squared minus 1, right? Dividing both sides by negative 1 is basically just going to change the sign of everything over here. And now I'm going to get rid of the exponential that's here. So I'm going to take the natural log of each side. And when I do the natural log on the left, the natural logarithm and the natural exponential are going to cancel out with each other, just leaving us with the exponent. And then we're going to have the natural log of this entire side. And I'll get myself a little bit more space here at the bottom. because there's one more step, and the last step would be to get y entirely by itself. We have to divide by -1 once more, which is just going to, there's really one great big piece on this side. Now within that piece there are several terms inside that quantity, but I'm not going to change the sign of everything inside the natural log. When I divide this entire side by -1, it just changes the coefficient of the natural log function from +1 to -1. And so this would be my specific solution. Now the one thing you have to watch out for here is the fact that we have a function written right here that doesn't have a domain that would include all real numbers, right? We can't put any old value in place of these x's and then evaluate the natural log of any old value. So you have to kind of be careful with that from time to time. The question doesn't really ask for the domain at all, but if you wanted to find the domain of this, you'd have to make sure that what's inside this set of parentheses is positive, and also that that interval that you list includes this x value. Our solution definitely has to hold at the x value of 1, but they don't really ask us to do that. They just ask us for the specific solution, and here is that solution.